Welcome, this is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium. This conference would not have been possible without our sponsors, PQ Shield, SSL.com, Entrust, Keyfactor, HID Global, and the organizational support of the Post-Quantum Cryptography Working Group of the PKI Consortium, and in particular, Entrust, Keyfactor, and Logius. Would you like to join the PKI Consortium? Go to pkic.org/join, or contact us if you would like to become a sponsor.
We're going to continue on with the forum today. So again, it's my pleasure. My name is John Buscelli again. I'll be acting as the moderator today, continuing our discussion on really the whole issue of PKI migration and transformation. This next talk by Mike Onsworth from Entrust will advance this topic entitled Architecting PKI Hierarchies for Graceful PQ Migration. I'm interested in the term graceful for the purposes of today. So without further ado, Mike Onsworth from Entrust. Thank you very much.
Morning. So first I want to say I have effectively spent my research career so far focused not on the crypto itself, but on the migration problem. So I've been active in the PQ area since 2017, and yeah, largely as the moving to it is going to suck, how do we make it suck less? Is sort of the general field of all my work. And as was perfectly called out, I have already lied to you on my title slide. That word graceful doesn't really belong here, but let's see what we can do about it. So, agenda for this talk. I first want to introduce, and I think this will be non-controversial for everyone in this audience. X509 is complicated. X509 is used in a lot of places. You cannot take all of X509 and say one solution fits all because of the very diverse ways that it's used. We talk about, okay, so if you're going to migrate, which algorithm do you pick? That's your first stumbling block. And then that leads into what I call the migration toolbox. And most of these are things that I've done research on. I've published papers, or I'm an author of an IETF draft on various versions of this. So what's in the migration toolbox? I don't think we can make this graceful, but I think we can make it less horrible. Maybe. Okay, so the migration problem and the long tail of X509. So we typically think of certificates the overwhelmingly large use of certificates is HTTPS. Sometimes we think of VPNs, we think of code signing, maybe we think of 802.11 Wi-Fi certs, we think of EIDAS and PDF signing. Those are all what I think of as core uses of X509. And not to downplay the problem, moving those to PQC is already hard. But as we get further to the right of here, as we get more into the long tail of sort of weird and specialized uses of X509, the migration problem becomes even harder. Because now you have hardware that you can't patch. You have hardware that's, printed into the cover of a passport. Do you just ask your citizens to come back and patch that chip? Like, no, you can't. So the farther onto the tail you get, the weirder your migration problem is, the more snowflakes, the more sort of weird we're going to have troubles. We have to think about this. We can't upgrade the hardware, or we can upgrade the server but not the client, or we can upgrade the client but not the server, or all of these things, all variations become possible if you go far enough out on the long tail here. Okay, so we know it's going to be hard. We know that we're going to deal with weird things everywhere we look. Let's go on to the first question that should be obvious is, which algorithms do we pick? That should be obvious, right? NIST has been working on this for years. We have algorithm standards. Which one? Uh-oh, this isn't clear. So this is a slide that I've put together for my own understanding, my own notes. I'm not even sure that it's correct or complete. But in just trying to understand, we have all these governments who are starting to put out recommendations, and they don't all align with each other. So the first question you need to ask when looking at which algorithm to use is, which government regulations even apply to you? Like, we see the strictest circle here is the NSA and the Australian recommendations, which allow only level 5 primitives. They disallow SHA-256. They disallow SLH DSA. That's a very tight set. Does that apply to you? Is the products you make, as the services you offer, actually covered by these national security classified standards? If not, you're allowed to look a little bit broader. What about hybrids? We have some governments saying hybrids are required. We have some governments saying, we don't like them, but we'll accept them. So do you consider hybrids in your solution? Do you make a product that's configurable, in which case maybe you support 3 or 4 configurations and allow your customers to adjust it to the location? Or do you make a hardware product where you have to make one configuration in hardware and then sell it to all markets? Like, this is complicated, and I unfortunately do not have an answer. I just have questions. Yeah, this is hard. This sucks. Good luck. What else might you ask yourself? You might ask yourself, so if you're considering your own migration, the first question we already talked about, do you have compliance or regulatory requirements? Do you have long-term data security requirements? Does your data need to remain secure for 20 or more years? I heard a great example in 1990, whatever it was, 3, the details of Donald Trump's bank loan from Deutsche Bank, whatever, like any other business loan. Suddenly, 20 years later, in 2015, the details of that bank loan became of extremely high public value, and the servers that were holding that data became target to public attacks. No one would have predicted 20 years ago that that particular PDF was going to become of extreme public importance. So you don't, does your data need to remain secure for 20 years? That's a question only you can answer. Do you control your environment tightly enough that you can upgrade everything all at once, or do you need to consider a more staged migration? If you are doing a staged migration, do you have only negotiated protocols like TLS where old things and new things can negotiate, or are you in a harder version where you're producing data with no knowledge of who's going to consume it? These are all, et cetera, et cetera, et cetera. There's lots and lots of things to consider, each of which leads to weird edge cases, branching decision trees. It's not simple. Okay, so depending on how you answered all those questions above, what's in the toolbox? And I like to say that if a plumber comes to your house, they don't just bring a screwdriver. The plumber comes with a whole bag of tools so they're prepared for any situation they might encounter. And I think that's the same with the PQ migration. If you just show up with MLDSA, you're going to find that you're ill-equipped for some weird migration problems that you're likely to run into. So what's in the toolbox? The first one I call Flag Day. This is, we control everything. We can just decree, we can decide on January 1st, we turn on post-quantum and we turn off RSA. And if you can do that, that's great. You should do that. That is the easiest possible way to do this migration. January 1st, PQC on, RSA off. Most people can't afford to do that. Most people need some sort of staged migration. So then we're looking at usually hybrid solutions give you the staged migration. Not all of these are strictly hybrids, but mostly if you can't do a Flag Day, then you're looking at hybrids. And so here's various versions, and I'm not gonna spend time on this slide going through them one by one, but I will go through them one by one in the slides coming up. So, what's our first one? Mixed PKIs. This is the idea that you use a different algorithm at different layers of your PKI. Today, if you're doing an RSA 2048 PKI, you just do RSA 2048 top to bottom, easy, done. That is probably not the best way to deploy post-quantum. So we typically see mixed PKI proposals look like this, where you have, typically you put a hash based at the top. This is the most common version we see. You put a hash base at the top, that gives you your extreme long-lived security on your root. Your root is typically not very active, so you're not typically caring about throughput on it. You're not, if you go with a stateful LMS or XMSS, you're not typically concerned about producing too many signatures and overrunning the counter. So hash-based makes sense for a root. You're issuing CA, you need to be a little more careful, but you also care about throughput, so maybe you put a hybrid there. And then your end entities is where you care most about performance, you care most about size. Your end entities will be generating most of your network bandwidth, so there maybe you go pure post-quantum, or maybe you have things that aren't really all that sensitive and you can leave them on RSA until 2034. So this is sort of the typical setup that we see for a mixed PKI setup is change your algorithm at each layer as you go down. RSA can stay active at the bottom. You can sort of slowly move stuff over to MLDSA as they support it. Cool. Lots and lots of flexibility built into this model. Multiple certificates, or what we call parallel PKIs. So this is sort of similar in that your end entities are still getting sometimes an RSA cert or sometimes an MLDSA cert. What makes this a little different is that here we are not mixing algorithms. We're keeping algorithms pure all the way up. And this is sort of attractive because that thing on the top is what you already have today. So you just keep it and you add a new thing next to it. And that's sort of nice to deploy. The disadvantage of doing this, so the pro is that your operations people are going to like this. It's very straightforward for operations. The downside is you haven't made the complexity disappear. You've just moved where the complexity is. And now you're moving the complexity from the PKI operations and you're moving it to the application developers. Because now the applications need to know what to do with two certificates. Either you use the first one or you use the second one, but when? When do you use the first one? When do you use the second one? Or do you combine them into a hybrid at the application layer? How do you do that? We need standards, we need protocols. So this looks simple because it's moving the complexity off the slide. It's not eliminating the complexity. So this works really well, and I highly recommend multiple certs for negotiated protocols. TLS, IPsec, SSH are all things that can pretty well handle multiple certs rolled into a single handshake. So if you're entirely doing online negotiated protocols, I highly recommend that you do this. Where this gets extremely complicated is for offline or non-negotiated protocols. SMIME, PDF signing, code signing, typically anything that involves smart cards. This is going to get really complicated. And in particular, okay, so I've got two certificates. What do I do with my two certificates? How do I take my two certificates and sign one document? Do I use one? Do I use the other? Do I use both? When do I use both? How do I combine them? I think outside of TLS, this approach becomes very complicated very quickly. And I just want to point out here, some protocols already allow you to do clever things. I'm not going to go through this in detail. Some protocols already allow you to do clever things with two certificates. CMS in particular is extremely well standardized and robust. But as you go down the list, XML, DSIG, JWTs, it becomes less and less clear how well the multi-cert thing is going to be supported. And if you have to then modify the protocols and deploy new patches of the JWT layer, well, now you have to modify software anyway, so you're sort of losing your value. So that was hybrid. The last slide was can you get graceful backwards compatibility? This slide is can you get hybrid security? Can you get dual security? And again, CMS, absolutely yes. CMS is very feature rich. Everything else currently has no way to get hybrid security with multiple certificates. Okay. There's one other trick that goes in the multiple certificates bag, which is an internet draft called related certificate descriptor, which allows you to cross-link your two end entities. So you could do your multiple certs, unrelated chains, and then at the end entity layer, you have a link, what we call this RCD extension, which says, by the way, it says, I'm an RSA certificate, but by the way, an MLDSA version of me exists, and here's a URL to go find it. And you do that in both directions, and now no matter which certificate you have, you can easily find the other one that belongs to that person. So this makes multi-certs a little bit more graceful, but a little bit. Let's talk about this one. This is the alt subject alt public key info, which is standardized in ITU's 2019 X509. It basically hides a second signature and a second public key in an X509 v3 extension. Puts it non-critical so that legacy clients will just ignore it. And that sounds great. And in some contexts, this is great. If all you care about is backwards compatibility of the 5280 validator, of the certificate chain parsing, if that's the only thing you need backwards compatibility for, here's a cert, please parse it, don't explode, then this does that. But again, it has the same problem as multi-certs. Well, it has the same pro as multi-certs in that it's very easy to deploy. But it also has the same con as multi-certs in that now at the bottom I have two keys, and what do I do with two keys? Do I use one? Do I use the other? Do I use both? We have a panel discussion, I believe, tomorrow. Wells Fargo and Wolf SSL and Keyfactor have been working on a test lab to try and make this idea work in TLS, and the results are, let's say, highly mixed on whether this is actually deployable or not. Okay, so that takes us then to composites. If you want true hybrid, you're into composites. Composites says, effectively the concept of composites, I think actually we'll just stick with the picture. The concept of a composite is you have one key and inside of it is two algorithms. But it's one key, it's one public key, it's one signature, it's one thing, one atomic object. Yeah. Inside there's multiple algorithms, but just ignore that. Just pretend it's one algorithm. So anything that handles one algorithm handles composites, and that's great. And it gives you strong hybrid security, and that's great. It doesn't have, I didn't put definitions in this slide deck, but it doesn't have backwards compatibility in the sense that old things can parse these without blowing up. Old things that try and parse these will in fact blow up. So it needs to be coupled with one of the mechanisms above. It needs to be, you can do one of the things we mentioned above with a composite to achieve backwards compatibility. But we say that this has protocol backwards compatibility in that you don't need to modify your protocol. It's just a new algorithm the way you would deploy any other new algorithm. Your protocol handles one signature. We provide you one signature from composites. So in that sense, it's nice. You don't need to change very much code to deploy composites, but it doesn't get you the old things talk to new things property. Bonus, composites is the only thing I've mentioned in this slide deck that gets you hybrid encryption. There's lots of ways to do hybrid signatures. Composites is the only one that does hybrid encryption for PKI. So it's got that going for it. And that takes me to the end. So at this point, I will read through this slide. So Flag Day, if you can afford to just say everything stops on January 1st, great, highly recommended, do that. Otherwise, you need to look at options. And so you could look at mixed PKIs, gets you the ability to fine tune your security properties and also your bandwidth and performance properties as you go down the hierarchy. If you're doing largely negotiated protocols like TLS or VPN, I would recommend a multi-certificate approach where you just issue all your entities an RSA as usual and then a new PQ and let them negotiate online which one to use. If you're doing non-negotiated protocols, then you're looking at either the hybrid Catalyst, Chimera, AltPub, whatever that thing's called, with all the complexity of how do you actually use it, or you're looking at composite. So it's a toolbox. At IETF, we're trying to standardize all of these things so they all have stable, mature standards, and then we can let the community decide which tool best fits the migration problem you're trying to solve. And you may end up using more than one of these together at the same time. Some of these do couple nicely with each other. And I think that takes me to the end.
We'll take questions from the audience and remotely now, but I do want to correct Mike on one comment. I thought you handled a complex subject very gracefully, so thank you very much. All right. At this point, questions from the audience, please.
Thank you for the enlightening lecture. Do you see commercial or common tool sets that implement several of these mechanisms? And that's not only tool sets for PKI, like EJBCA, let's say, but things like servers, Tomcat, WebSphere, clients, Edge or email clients, things like that?
Yeah, it's a tricky question to answer, partially because, of course, I can't pump products here, but my company would like to sell you some. Also because it's a bit of a cart before the horse. I mean, we're still arguing over the standards, and you need the standards to be final before vendors are going to jump in and spend R&D resources. So I think I can say at the IETF, so I run with my coworker, I run an X509 hackathon group that's been meeting for 8 or 9 IETFs now. Many vendors are up to, I think, 15 participants in that. And so we are getting some deployment experience, at least in the hackathon, of hybrids as well as pures. It's coming, but I think the standards sort of need to solidify first.
Thank you.
Chris, a remote question?
Okay.
Go ahead, please.
Yes, I have a question, a technical question about the link certificates. I don't see how they work, at least as you point them out. Yeah, that one. If RSA is, oh, you don't claim you don't have hybrid security. Oh, okay. Then what's the point?
Thank you, Scott. So the problem that this is solving is I've emailed with you before. Your email cert is in my Windows cert store. If I go to Outlook and I type email Scott, it's going to pop up and use your cert. How do I know that you now have a newer version of this cert?
Okay, thank you.
This is solving the discovery problem.
Okay.
It is not, you could, if you wanted to be really clever, use it to solve the security problem, but the main goal here is how do I learn that a second version of this certificate
okay,
exists?
thank you.
Client that does not know about it. And I want them to just gracefully ignore the post-quantum parts of this. And that's what this accomplishes. So the outer RSA signature can be validated by any legacy client, whether it's been upgraded or not. And then if my peer is upgraded, knows about the certificate format and knows about the MLDSA algorithm, then it can opt to use that optional part that's buried inside it. So you need to be a little bit careful. And this is, again, why it's complicated. Exactly what properties this gives you is really specific and really depends on what backwards compatibility properties and what new things are talking to what old things. So the use case for this, in my opinion, is real, but fairly narrow.
Great. Next question from the audience.
Yeah, so question on the embedded systems related, right? So if there is a small piece of hardware that is part of a big, large ecosystem, like a hard drive or a network card or something like that, which has its own identity certificate that is issued today, and from a verifier, from an attestation ecosystem point of view, right? I have a verifier in the fleet manager level or at the chassis BMC level, which is verifying certificates. How long do we carry that forward for the existing X509 and all the other different schemas of all these hybrid certificates? How long do we carry forward? Is there a transition plan from a verifier point of view?
My first answer is I can't answer your question for you about how valuable your data is. I can't give you timelines. A consulting company who has experts in PQC could help you look at all the details of your deployment and figure out, does your data have 5-year value or 20-year value? I'll give credit to Professor Nadia Hanninger. She introduced a really interesting concept earlier this year called quantum annoying, which is that Scott, maybe she didn't introduce, but she certainly used. Quantum annoying is the idea that RSA and elliptic curve, like Shor's algorithm, is not free. Quantum computers will be large, they'll be expensive, they will take time to run, they will not be instant. So depending on the value of the data, like is that network card identity, is someone willing to spend $10 breaking that identity cert? Is someone willing to spend $1 billion breaking? Probably nobody's going to spend $1 billion to break a single certificate for a single network card. And so at some point you might decide, well, maybe this is low enough value that quantum annoying is a good enough property for this security system.
Time for 2 more questions.
Yeah, thank you. So when I look at hybrid certificates, I can't help but thinking of the XKCD comic about standards. There are 14 standards. We want to make one more that takes all of them, and there are 15 standards. My question is, do you think that this is the complete overview, or there are still things that, okay, we are missing this, we need another standard for this? Is this a complete toolbox, or do you think there's still more that is missing?
I have to be careful how I answer this because I'm an author on more drafts than I even put in this slide deck. In my personal opinion, the long tail of X509 is very long. I think some of the embedded systems uses of X509 are going to have extremely complicated migrations. I think there is still room for more mechanisms. I think there are still I think there are still migration problems that are not well covered by any of the mechanisms in this deck. But I also take your point that as we get into extremely niche cases, do you really need a public standard for it? Or is that something that can be solved in a proprietary solution?
Last question.
Nicely done. You only lost me on a couple of slides as a novice. Thank you. So on your toolkit matrix, is there can you put a painfulness scale on the options there? What should I stay away from?
I can't because I don't know what you're trying to migrate. I don't know how complicated your system is. I don't know how much control you have over pushing patches. I really...
Well, minimal, obviously, most of the time. Yeah, I just wanted to, also on your long tail chart, is there an overlay of this onto the long tail and the things that you had on there?
Honestly, it's hard for me to stand at a microphone and talk about this in the abstract. Like, this is where I think, Alessandro said, I think quite well, that you'll need to involve PQC experts. I do think there's a role for consultants in this migration. I think the details here become very detail-y very quickly, and how this overlays with the matrix, I think, is hard to summarize in the abstract. I think it really depends on exactly what you have, exactly what's trying to talk to what, whether you can get them back and replace them or not, or I think all the details matter. I don't think that's easy to answer in abstract.
So we're done, but so if you had to point to one of those, is there a danger, Will Robinson, on that chart that I should stay away from?
Passports are hard because you can't get them back. You can't patch them. eSIMs are hard for the same reason. That's the, I fired it into space on a satellite type problem. I think that the less contact you have with the device, the harder the migration problem becomes.
Thank you.
In the mixed model on the bottom layer, is it a good thing then to shorten the life of?
Okay, that's nice.
Because in your mixed model, you say we could keep at the.
Question is, in the mixed model, where the bottom layer is only RSA or only MLDSA.
Would that make sense as well then to shrink down the life of that level and increase the rotation? Say like, okay, because we know there is a risk. Okay, we keep RSA, but we make it 3 months, reduce down, and then we rotate every 3 months. So that
reasonable strategy. I've heard people try and analyze this in a formal way and say, what's the fastest that Shor's algorithm could ever run? If Shor's algorithm would need at least a week to complete, then rotate your RSA keys more than once a week, and seems like a valid strategy to explore. Yeah, I mean, you're forcing the adversary, if an adversary is doing harvest now, decrypt later, you force them to break, instead of one key to get 10 years of data, you force them to break one key to get a week of data and then have to break another key. That's going in the direction of quantum annoying.
Yeah,
you're not fully quantum secure, but you increase the amount that someone has to spend on quantum computers in order to, and again, depends what you're protecting. If you're protecting military secrets, or it's the root key for the MasterCard environment, you care a lot. If you're protecting a $20 gift card, maybe you care a lot less.
Okay, thanks.
You said there was a question for
Test. Yep. Okay. There was a couple that came in a little late, so good chance to field them. One of the questions came in was around as ECDSA certs are often already there as part of your roots and have been distributed amongst devices and organizations, root of trust management. Any comments on handling a mix of RSA roots and, for instance, MLDSA or other algorithms downstream and intermediate CAs, or even on the issuing CAs?
It didn't end the way I expected to end. Can you read the last sentence again?
What are the implications of mixed protocol type of environments where, for instance, you're running can you run an RSA root and say an MLDSA or post-quantum protocol at the other layers in your PKI?
Right, I understand the question. So you need to ask yourself questions about what security you're trying to achieve. Because in a model like that where you have classic at the top and then post-quantum at the bottom, your message will be protected by post-quantum. So the actual over-the-wire encrypted or signed object will be protected by post-quantum, but the long-term trust of the system is not. So if you're worried about man-in-the-middle attacks where someone comes in with a fake certificate, well, you're doing nothing to protect creating forged certificates. So in general, I don't think there's a lot of value in issuing stronger leafs off a weaker root. But maybe there's some niche case where that does make sense, where your security model happens to be exactly, I care about wire messages, but I don't care about trust stores. Maybe there's a use case like that exists in the world.
We've definitely seen crazy things in PKI, and you're in my time, so wouldn't surprise me if that use case isn't out there somewhere.
I have seen certs used for insane things. Yes, correct.
The other one that came in, and I'm just trying to mash up a couple of different questions here that came in along the same lines, and they have to do with the hybrid approach and with all the different ways that hybrid are starting to come out and some of the complexities. Isn't the compatibility going to start to become an issue sort of on the internet, if you will, or more than in the environment? Like, how are organizations supposed to try to rationalize all these different hybrid approaches into something that's going to work at a larger scale or a mass scale where they may not have control over the endpoints?
Good question. I mean, Brainpool versus P256 already caused chaos, and now we need like a 5-dimensional grid to represent all the choices and regional variations and protocol variations and hybrid versions. Yeah, it's going to be a mess. I don't have an easy answer. I mean, I think the best we can do is recognize that the different tools solve different use cases, and you probably don't need to implement all of them for every software stack. You implement the ones that make sense for your software stack and for your use case. For example, I'm not actually convinced that, like, composite is my baby. I've pushed composite. I'm actually not convinced that it makes sense for web PKI. TLS is a very constrained use case, and where maybe composites doesn't fit, in which case maybe it doesn't make sense to have any composite in web PKI and TLS. So I think you can be a little careful and not implement everything depending on what you actually need.
Those are all the questions we have remote right now.
I had a question for you. If there are no more from the audience. In your discussion, you were sort of giving guidelines and outlines on how to prioritize or set criteria for the application of these different schemes. Can you just comment further on what advice or guidance you might give to this audience on how to choose and select algorithms for various layers of the PKI infrastructure?
You want a flowchart. I have actually tried to write that flowchart several times, and the font got too small, and then I stopped. I mean, unfortunately, I think that it does require expertise. I think navigating that matrix of use cases and security requirements and migration requirements and available tools, at the moment, there's no easy way to flowchart that. I think it really does require people who have expertise on.
Sounds like a topic for the... Okay. Again, thank you very much, Mike. That was fantastic. Well done. Well done. All right.
How do you get to a quantum safe state? That depends on the current state of your digital security infrastructure, as well as your level of visibility, control, and automation over those systems. Check your level of preparedness with the Entrust Post-Quantum Readiness Assessment. Whether you're already on the path to quantum safe or just beginning your journey, Entrust can equip you with the right knowledge and solutions. There are many paths to a quantum safe future. Secure yours by taking the Entrust Post-Quantum Readiness Assessment today.